Okay, so this video is about topic 1.1 of precalculus. So we're going to be talking about concavity, increasing and decreasing, positive and negative, and some tricky wording. Because on that test, they used all these words, but they used them in contexts that you wouldn't really think of. So we're going to start with concavity. Let me zoom out a little bit here. So, concavity. When something is concave, that means that the rate of change is either concave up, which means the rate of change is increasing. So let's take a look at right over here, right here. So as you can see, from this point, the rate of change, although it's going down, the function is going down right now, the rate of change is constantly increasing. That means that's concave up. Concave up, ROC up, right? So even if, even if this half of the function was gone, since this is ROC is increasing, it's still concave up. It doesn't have to look like it can hold water. That's a visual indicator, but that's not what's important. What's important is that the rate of change is steadily increasing, right? Concave down is the opposite. So as we have concave down, our rate of change is decreasing. Even if we're increasing at some point, doesn't matter. It's decreasing over time. So our slope is slowly getting closer and closer to zero, and then it's going down and down and down. So one way you can think about it is that this is the speed of, let's say, the speed of a train. So when you're concave up and your speed is going negative, you're pumping those brakes. You want to stop the train. So you're slowly stopping, and then now that you've stopped, you want to switch directions since you're still concave up. So you want to increase that speed or that rate of change over time. So you're increasing, but then now you're concave down. So you're going on the brakes. So you want to get as close to zero as possible. Go to zero, reduce your rate of change. And now that we're at zero, we go the other way. So we just want to increase speed that way now. So I don't know if that's a very good analogy, but it's how I think about it. So let's do this little example part. So let me remove this. If we were to go from -7 to -4, this area right here, is this concave up or concave down, or neither? I'll give you a second here. This is, as I said before, this is concave up, and that's because the rate of change is increasing. It does not matter if the function is going negative right now, which we'll discuss later. It is the rate of change, the line like this. If we were to draw a line tangent to this, which what that means is essentially if we were to continue on the same route, we would just go like that, right? But if we continue on this route and go a little bit farther out, our line would be a lot less steep. That's how we know that it's curving up and that it's concave up. So concave up really wants to go up, even if it's it has downward momentum. So this is let me erase these points. Concave up. How about 4,7? 4,7. Now this right here really wants to go down, and it is going down. The train stopped, and now they're going the direction they want to, which is down. So that means that is concave down. Concave down. 0,4. 0,4. Now this one, even though it's going up, it really wants to go down, so it's slowing down, which means that it's concave down, because it's trying to go down, so it's slowing down its upward speed, putting on those brakes, and then going back down. So this is concave down. And as you probably guessed already, we have -4, 0. This one really wants to go up. The brakes were successful. We stopped, and now we're going up. So that's concave up. Concave up. Nice. So that's concavity in a nutshell. There are some tricky wordings with concavity, but we will be going over them near the bottom. So now, increasing and decreasing. Now notice how I say in terms of f of x. Now you need to pay very close attention to what is increasing or decreasing. And again, I'll cover this more later, but just make sure you keep in your head that we're increasing and decreasing in terms of f of x, in terms of the function, in terms of the y. Right? Because f of x is just y, right? This is the y value. It's a function of x, which means the y value depends on the x, but essentially, operationally, it is just the y value. So, when we're increasing, we have a positive slope, because the y value is going up. Doesn't matter if we're concave up, concave down, that has no correlation. If we're increasing, our slope is positive. If we're decreasing, our slope is negative. If we were to continue going on the path that this is traveling without changing ROC or anything, like that, we're going down. If you were to roll a ball from left to right, it would roll downward. So that means you're decreasing. And if we were to continue this way, if you roll a ball from left to right, it wouldn't roll up. It wouldn't be able to go up that hill, it would fall, which means that we're increasing. I might have missaid something and accidentally said something, I don't know. Anyways, so let's do this example. I'll give you a second here to do it on your own if you want to. -7, -4. Now, while this is concave up, that has nothing to do with increasing or decreasing, because the y is getting smaller. As you go to the left, the y is going down, which means it's decreasing. Concavity doesn't matter. I don't care. I'm only looking at whether it's going down or it's going up, or it's doing neither. In this case, it is decreasing. I forgot to delete my points here. Alright, now we got 4,7. 4,7. Now, this, as you go left, y is going down. So that means it's decreasing. Easy. Now, you could do the tangent line trick where you say, okay, let's pick a point here, and then let's draw a line like that. I don't like to think of it as a tangent line. I like to think of it as, imagine this is like a hill, and then you're putting a point, and imagine that point is like, it's like the triangle of a seesaw, and you're just trying to make it as close as possible to being straight. So we have our triangle of our seesaw, and then we're making it as close as possible to being straight. I like to think of that better than just saying, oh, draw a tangent line, because tangent line, it's overcomplicating something simple. So we're going to draw our seesaw right here, and we're going to notice that's going down, right? So it's decreasing. Now we have 0, 4. 0, 4. Now on coordinate planes, I like to specifically mark out my intervals. And what I mean by that is, like, when I am given an interval, I will draw a point on each, or like even a line on the interval, just so I make absolutely sure that I'm in the right spot. Even if you erase it after, it's just really important that you know where you're at. So 0, 4, we're going up. Even though our ROC is decreasing, even though we're concave down, as you go right, y goes up. That's all that matters in terms of f of x. When f of x is increasing, you go right, y goes up. Right? So this is increasing. And once you know it, from -4 to 0, we are also increasing. Because as you go right, y goes up. Very, very easy. And you may be asking like, oh, how did I get that wrong? We'll get to that. Next thing we're going to cover is positive and negative. Again, in terms of f of x. I love word problems in math. I love reading comprehension in my math class. Positive, in terms of the function, in terms of the y value, is above the x-axis, and negative is below. Very, very simple. I'm not even going to go through all these examples, because really all you have to do, boom, I'm done. Anything above is positive, anything below is negative, anything on the line is neither. Easy, right? You know what a positive number is, you know what a negative number is. If y is positive, then y is positive. And if y is negative, then y is negative. Right? Easy peasy. And now we get in to the annoying part. The wording. Right? When we say increasing and decreasing, when we're talking about a function, let me get a highlighter here. You see how this is going up. As you go right, this is going up. This is going up, even though it's concave down. These are all going up. And then decreasing, these are going down, these are going down. Concavity does not matter. However, that is when we're talking about the function. Whether the y value is increasing or decreasing. When we're saying increasing the rate of change, that's where we have problems. Because the rate of change is what's increasing. We could have a function. Here, let me find it for you. We could have a function that looks like this, right? We're increasing. This is increasing. But if it's asking for whether the ROC, the rate of change, is increasing, you have to say, no, it's decreasing. Because as you go right, it goes up less and less and less and less, and finally approaches 0. Very important distinction. If it's asking about the function increasing, yeah, that's increasing. But if it's asking about the rate of change, the rate at which the function goes up, the speed at which the train is going towards the top, the speed is decreasing. We're approaching 0. So the ROC is decreasing. So very important thing to keep in mind. Same with decreasing. Same concept there. If rate of change is decreasing, you are increasing the speed at which you are going down. You are going faster downward. You are not. It does not mean you're just going downward at all. Right? So positive and negative, when it comes to rate of change, the rate at which the function is moving is positive if it's going up, and it's negative if it's going down. Now, very important distinction. Very annoying distinction. My Control Z is not working. Sorry. When it's in terms of the function, if it's positive, it's just above the y-axis. I mean the x-axis. It is above that line right there. Right? It can do whatever it wants. I don't care. As long as it's above that line, the function, the y value, is positive. You know what a positive number is. Negative, negative. Right? But when you say rate of change, essentially just think of it as positive rate of change. It's just positive slope. If you were to draw your seesaw, right, you would be going up. If anything, it's the same. These two are the same. Having an increasing y value and having a positive rate of change are the same. But they use different words that can be used for very different things, which is really easy to get tripped up on. Another thing I have here is, one of the questions on the test said, the rate of change is like when the rate of change is increasing linearly. And what that leads you to think is, oh, right, this is what we're thinking of, because our rate of change is linear, right? Unfortunately, that's not how it is. I know it sounds really similar, but what it's actually meaning is something like this. Because as we go up, as we increase, we have 1, 2, 3. So we're essentially, our linear equation for our rate of change is just x, right? And that may be really confusing the way I explained it, so I'm going to try to take it from a different angle. The rate of change is increasing. And what I mean by that is that it is getting bigger. We are increasing more for each equal interval. So I'm stepping the same distance, right? But each time I'm going higher and higher and higher, right? But it's by equal amounts. So this is 1, this is 2, this is 3. That's linear, right? Because you add the same number each time. It's a straight line. If you were to graph this, the rate of change instead of y, that would be a linear equation. So you're increasing your rate of change in a straight line. And you may be saying, okay, well, what do you mean by that? Let's compare it to, let's see, yada yada, should have drawn this before, but I didn't. Let's compare this to this. So 2, 4, and instead of going, so we have rate of change increase of 1, sorry, rate of change is 1 here, rate of change is 2 here. Instead we go to 8, rate of change is 4. That's not linear. Have you ever seen a linear equation where it goes like that? No, because that's an exponential equation, right? So when your rate of change is increasing linearly, that means that it jumps by the same amount each time, equal steps. And although the function may look like this, the rate of change will look like this. So when we're talking about rate of change, you can't worry about the function as much. You have to really focus on what they're asking for. That's all for this video. If you have any questions or any comments, anything that you'd like me to add, any questions you have, let me know in the comments, or just tell me. Literally just walk up and tell me. I'm considering doing this on a physical whiteboard, because pre-drawing stuff has been working pretty well. I don't know. You guys let me know. But this has been topic 1.1. I hope this helped some people and cleared up some stuff about that test. And yeah, that's all. I'll see you in the next one. Next one should be 1.5, I believe. I don't know, we'll see.